I should have made this one a little more challenging. This was pretty easy after we've done all that. What's the name of that one? Let's make it more challenging. Come on, this one is too easy the way it is. How about we do that and that? Now what's the name?
I don't believe we said like the 3, 4, 5, like, because is it on the functional groups at just 3 and 4, and then you.
The ones that I circled, 1, 2, and 3, those are the 3
Yeah.
methyl groups as functional groups. So that's carbon number 1 in the parent. You okay with that?
Yeah.
So carbon number 1, 2, and 3. So carbon number 3 has a methyl group on it.
Yeah.
Carbon number 4 in the parent has a methyl group on it. And carbon number 5 has a methyl group. Which part don't you like?
Like,
You okay with the 3 and the 4?
like, didn't you say you go in order? So it's like.
We start with the part that's scribbled through is like the backbone of it.
Right.
And then everything is branching off of the backbone. So we've got 3 different branches coming off of, and I know it's weird that the backbone is crooked. It's got scoliosis or something, right? Because that is part of the parent. But this CH3 that I circled is not part of the parent. It's branching off of it. And it's branching off of carbon number 3 that's in the parent.
Okay, gotcha.
And so is that one, and so is that one, yeah. So we called that one number 1. I didn't want to call that carbon number 1 because that would make the numbers too big.
Okay.
All right?
Yeah.
Okay.
Yeah.
Yeah. I know it's when it's all horizontal, it's so simple and obvious, but yeah. But there, you got to watch out for this kind of thing too. Yeah. Okay, what's the parent on this one?
Heptane.
This one is a heptane parent. Yep. It's 7.
Yeah.
Yeah, okay. So there's a bromine, we would call that a bromo group. And then a methyl group on it. Who's got the name? You want to try this? Come on. Okay, okay, time out. I can't remember. Emily. Okay, Emily, sorry. Yes, but you know how in this case we put all the numbers first and then we said what the functional groups were? That was because they were all the same. All of them were methyl groups, so we said trimethyl. Yeah, so you have to keep the number with which functional group it belongs with. It would be, that's right, 2-bromo dash 5-methyl heptane. I'll just put HEP period. You know how to finish that one. 2-bromo 5-methyl heptane. Good job, Emily. Good job.
Thanks.
She owes it all to you, doesn't she? We all right so far? We're thinking we got some naming now under us? Okay, let's take the next few minutes and talk about when we have unsaturated compounds, these double and triple bond compounds. So far everything was saturated with all single bonds. And we have double and triple bonds to contend with. We're just naming, we're not talking about properties or reactions of them yet. We will later. Talk about, well, what do we do with an unsaturated compound to make it saturated? this original pentane molecule that I drew, this is considered saturated because there's nothing we can do to add more atoms onto here. All the carbons already have 4 bonds to atoms, and all the hydrogens, they can only make 1 bond anyway. And that's as many atoms as we can get out of this thing as possible. Now, in contrast, if this thing were to have a double bond somewhere in it, in order to make a double bond, I'm going to have to erase 2 of the hydrogens, because otherwise the carbon's not going to have enough electrons to make a double bond with another carbon. So, with 2 hydrogens taken off, I could get a double bond now between 2 of the carbons, and this would be an example of an unsaturated 5-carbon compound. Now remember, it was pentane when it was all single bonds. Now that it's got a double bond in it, we're going to call it pentene. Pentene. ENE is what ends when you have a double bond. We would call this compound, the classification would be an alkene, but this specific one is pentene. So it's unsaturated because we could do some reaction to cause that second bond to break and then 2 other atoms to be added to it. That's what we identify as unsaturated. Okay? What is the name of this now? Pentene. To call it pentene is not specific enough, because the double bond needs to be identified as to its location. This double bond is between the first and the second carbon. It could also be between the second, it could be there, between the second and third. That would be a different compound. It's kind of strange to think of, but it would be different, it had different properties, maybe only slightly. So we would call this thing 1-pentene, because the double bond is between carbons number 1 and 2. If the double bond was there, we'd call it 2-pentene. If the double bond was there, what would we call it? You'd call it 2-pentene again, because you're just looking at it from the other side. Yeah, still, because that would be carbon number 1, it'd be 2-pentene. Okay? So, yeah, with the numbering, just be careful to minimize the numbers on it. And I just have an example of that here, I think. Oh, yeah, here it is. Now, because the compound lost 2 hydrogens, the general formula for an alkene is CnH2n. Remember, the alkanes were 2n plus 2 for the H's, but now we've cut down by 2 hydrogens, so the double bond could be made. I think I actually have a pentene. Oh no, I have heptene.
So the name of the one,
What do you want to name it? It's 5 carbons, so it's pent, right? Yeah, it would be 1-pentene, exactly. Yep. So does it make sense how I've named this structure? It's got 7 carbons there, so it's hept. One of them is a double bond, so it's heptene, and we have to say where the double bond is, between carbons number 3 and 4. So we always minimize the numbering, call it 3-heptene. So if I said, hey, draw a structure of 3-heptene, you'd all make a structure like that. Yes? All right. And then just along the same lines, alkyl. I hit the shade, I think, on that. Alkynes are compounds that have a triple bond in them. These are not real common. Alkenes, there's a lot of those. Just a few alkynes. But it follows the same kind of a pattern. We'll end alkynes with a YNE. So like in this case, this is pentyne, but we have to say where the triple bond is, so that would be 1-pentyne. Okay, with just a couple minutes left, you all good with this slide? I'm going to skip this one, and I do want to tell you that in the reading, right in the middle of the reading, there is a little section in the margin of the reading that's about this, when you have a branch that has branches. This can get really complicated. I will not put that on the reading quiz. So you might want to write that down. It's in the margin of page 1027. The margin of 1027. You can look at it. I don't care if you look at it. But I'm not going to ask anything about it on the quiz. Okay? I'll start with this tomorrow, after the reading quiz. And cyclic compounds, we'll get to that tomorrow too. I just wanted to just go over one more example, and we'll call it good for the day. And you try to name this compound. Got it? What's the parent? I think it's an octane. Yep. So this one, there's no surprises. It's just they got that nice horizontal parent. And then we have, what's this thing? That would be an ethyl functional group. Ethyl. Yep. I don't call it ethane or anything other than just a functional group is like an adverb. You'd use a YL always for describing it. So yeah, it's an ethyl group. What number carbon on the parent is the ethyl group on? 4 ethyl octane. Yep. 4 ethyl octane. Anybody have any questions? Yeah. Go ahead.
Is it called ethyl because it's got 2 carbons?
Yeah, because there's 2 carbons. Now, some people don't like that I brought this down and made it curved like that. Why didn't I just put the CH2 and then the CH3 underneath it? I could have. It's fine. But yeah, this is perfectly fine to write it like that too.